In this video, we're going to be talking about the side angle side, or SAS similarity for short, theorem. And this tells us that if an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So this is really similar to the angle-angle theorem and the side-side-side, but now we put this all together. And so, for example, we see that triangle XYZ is similar to triangle MNP here because angle X is congruent to angle M, and I see that ZX over PM is equal to XY over MN. And so the sides are proportional, and the included angle, the angle between the two sides, is congruent. So let's go through some examples of using this theorem. So for this first one, I want to explain how to show that triangle SRT is similar to triangle PNQ. So I know I need a congruent angle, and then I need the two sides on either side of that angle proportional. So right off, I see that angle R is congruent to angle N. And that's because they're both right angles. So I can say that angle R is congruent to angle N by right angle congruence theorem. Now I need to see if my sides are proportional. So I'm looking to see if these fractions end up equaling the same thing once I reduce my fractions. And so I see that, looking at my similarity statement, that SR is similar to PN. So I'm going to have SR over PN. SR has length 24, so I have 24 over PN, which has length 18. And then I need to reduce this fraction, and I see that 6 can go into both 24 and 18. So dividing both top and bottom by 6, I get 4/3. And then that leaves RT over NQ. RT I see is 28, and Q has length 21. And then when I reduce that fraction, I see that 7 goes into 28 and 21, and so when I divide 7 from both top and bottom, I get 4/3 again. And so I see that these both match up. So therefore, I can say that triangle SRT is similar to triangle PNQ by side angle side similarity theorem. Okay, let's try another one. So here I want to show that triangle DEF is similar to triangle ZYX. So first I'm looking for a congruent angle. I see that both angle E and angle Y are 53 degrees. And so since they're both 53 degrees, that means that angle E is congruent to angle Y by the transitive property. And now I need to check and see if my sides are proportional. Here we need to be careful. These triangles are really reflected from each other, so we really want to look at your similarity statement here. And so I see that DE needs to be similar to ZY since they're both the first two letters in my similarity statement. So DE over ZY is going to be equal to DE is 30, and then ZY is 20. And then when I reduce that, I get 3/2. And then now I can do my other two sides. That leaves EF, which is my second two letters, over YX. So 24 over 16. Here I see that 8 goes into both 24 and 16, and so when I divide 8 from both top and bottom, I get 3/2, which is what I was looking for. So since I have a congruent angle and the sides on either side are proportional, I can say that triangle DEF is similar to triangle ZYX by side angle side similarity theorem. Okay, looking at one last one. Here it's a little bit different. I have two triangles, JKL and NML, and they both share that point L. So again, I'm looking first for a congruent angle. Here I didn't have any angle measures that were given to me like the first two problems, but we need to remember some of our angle properties. So here I see I do have and what we learned about vertical angles is that vertical angles are congruent. So I want to see that angle JLK is congruent to angle MLN by vertical angles theorem. Okay, go ahead and pause the video. I want you to finish this out. I want you to show that those other two sides are proportional, and remember to use your similarity statement to see which sides need to be proportional. When you think you have it, go ahead and press play. So when you're finding those proportions, you should have found that both of these ended up equaling 2, and so you can say that these two triangles are similar by side angle side similarity theorem.